Welcome to Pipe Tools. Today we're talking about the SeCorrPhon 06. The SeCorrPhon is a combination of a Aquaphon and a field correlator. So in other words, it's the combination of the Aquaphon A100 and the SeCorr 08 field correlator. Both units and all the software, firmware, are located within the SeCorrPhon receiver. They work very much the same. So in other words, if we take a microphone and we plug it into the device, the unit turns on. You can see M01, the hertz range that it's listening to, the scale, 3 levels of amplification, the volume in the headset is controlled by scrolling. And it has all the same features as the Aquaphon. So in other words, right now it's asking us if we want to filter. So if we want to filter, we press enter. And on the lower hertz range, we can either take it up or down by pressing the up button. By hitting the enter button and then the up button. Hit enter. Scroll down. Hit enter. And in our case, we don't want to listen to the whole hertz range. We want to take it down into a more reasonable level, down to say around 1200 or 1150, and hit enter. To exit this screen, we scroll down to OK and hit enter. You'll notice that there's a little speaker button on the left-hand side of the screen. To listen, we can plug in the headset, and there are 2 ways to listen. We can use a sampling button, much like the Aquaphon. We press and hold, and you'll notice that the X is out of the speaker, and we can now hear the noise in the headset. If we release, we turn off the headset. We can also listen full time by pressing and holding the microphone button. To turn the device off, we remove the microphone and the unit shuts off by itself. The SeCorrPhon kit comes with 2 EM30 contact microphones, not only for listening but for correlation. It comes with the T10 test rod with the heavy-duty, rather robust extension rods. It comes with the BO4 wind-protected microphone, the ground microphone handle, very comfortable to use. The soft soil microphone with a spike for going across the lawn. The spike screws into the bottom of the microphone, the ground microphone. Now that we've discussed briefly the SeCorrPhon's ability to use ground microphones to pre-locate and the test rod microphone to listen to valves and services and so forth, we now turn our attention to correlation. The SeCorrPhon is also a correlator. So to take advantage of the correlator function, we press and hold the on button. It goes through its logic. It tells you the battery strength in the unit. And the first thing that it asks you for is pipe data. You see that the pipe data symbol is highlighted. Normally when I'm out in the field, I like to listen to make sure that my microphones are set properly. And I also like to take a look at my components to make sure that my transmitter is putting out enough signal strength to be able to listen and get a good correlation. To do that, we go to the menu key, press the menu key, and we scroll down to components. We hit enter. And you'll notice that we have signal strength on the little pole symbol. And that tells us that our microphones are plugged in and operating correctly. And you'll notice that the EM30 microphones are processing noise, which is good. And we see that the receiver has battery strength. So we know everything is set properly, everything is turned on, and everything is working. Now, because we're working on the workbench today, what we'll do is we'll go back to the File button. There we go. And we'll go up to Listen. We'll hit Enter. This gives us the ability to listen to Channel 1, the ability to listen to Channel 2, or both at the same time. Hopefully we will be able to hear the noise at either one of those stations or both of those stations to tell us that we are indeed on the correct pipe that we're trying to correlate. Now we're back at the main screen, and the device is asking us if we want to enter pipe data, and we will say yes by hitting the enter button. These are 1, 2, 3 sections of pipe. Is it all, for example, 8-inch cast iron or 8-inch ductile iron for one continuous size? Or is it that you're working from a water service that might be 3/4 inch out to the main, down the main, to another water service that you would place the other microphone at? In that case, it would be 3 different sections of pipe. For the most part, we'll be using 1 section of pipe. Of course, we're working on the tool bench today, so we will just press enter, and the next thing that it asks us for is the distance between the 2 microphones. What is the distance in the pipe run from one microphone to the other? And we can enter that in 2 ways. We can enter that in by scrolling using the jog dial, or we can position the cursor over and use the up or down buttons to enter the footage. We then hit the enter button. Is it cast iron pipe? Is it ductile iron pipe? It's asking you what the pipe material is. We hit enter. The next question is the size. It's asking us for the diameter of the pipe. In our case, we'll scroll down to 8-inch and we'll hit enter. Then we scroll down to start. Hit enter, because that's what we want to do. We want to start our correlation. And what it does is it reviews the information that you've given it. You'll see that there's 1 section of pipe, the information that we've put into the device. The start button is highlighted, and so we can go ahead and press start. And it takes its first 32 noise samples. And we're actually doing a correlation just listening to the tabletop here. And of course, as expected, we're getting a lot of different noise sounds. Ambient noise sounds are winding up in the correlation. And this is true out in the field. When we place the microphones out in the field, we're listening to the pipe, but we're also listening to traffic noise, the dog barking, the bird singing, and the tree trimmer or the lawnmower. It takes its first 32 readings, and it measures the time delay. We're coming up on 32 as we speak. And it gives us a footage from point 1 to point 2. So from microphone 1 to microphone 2. So it's 162 feet from microphone 1 and 162 feet from microphone 2. And you'll notice that in the little box there, there's a 0 time delay. That means that no correlation was possible. We kind of expect that because right now we're just listening to the tabletop. There is no sound that both microphones hear that is the same, and therefore correlation is not possible until we take it out into the field and we actually listen to a pipe. We can also scroll down and continue. If we were out in the field and we got a correlation that we didn't particularly like, we thought maybe the time delay was too high or there was a lot of interference noise, we might want to continue and take more noise samples, which is very helpful. If we scroll down again, we also see that there's a filtering button. During the process of coming up with a result, we can also filter. We can filter out noises that we don't like. Of course, we want to stay in the leak noise range, and we can filter. Sometimes it's necessary to move the cursor being that dotted line that you see across the top of the screen there. That gives us the opportunity to look at more than one peak. We can move the cursor over and identify the footage associated with that peak that we see on the screen. So that if we know, for example, that Mrs. Smith is doing the laundry and that we get a peak at her water service, then maybe we would look at the next peak down to see if that takes us to a spot where we actually hear a leak noise. So the SeCorrPhon is a combination of a great listening tool. It's also a field correlator, and that's why we've kind of termed it the leak detection department in a box. We're working with the SeCorrPhon in the field this afternoon, and to work with the correlator side of the SeCorrPhon, we turn the device on by pressing and holding the on button. You notice that the battery strength is almost full. Before I start any correlation, I always like to check to make sure that the transmitters are working properly and the microphones are set correctly. To do that, I press the menu key and I scroll down to components. I hit enter, and you notice that our battery strengths are relatively full and that we have transmission from both of the transmitters and that we're hearing noise from both the EM30 microphones. To lower the volume in our headset, we can turn down the volume by scrolling that knob. At this point, I'd like to go back and I'd like to listen. Went back to the menu. We'll enter and listen to sound level number 1 and sound level number 2. And what we'll do is we'll reduce the level of noise in the headset. We don't want to hurt our ears. We have the opportunity to listen to channel 1, channel 2, and both together. So to listen to channel 1, I scroll up, and it automatically just listens to channel 1. Conversely, I can scroll down to 2 and listen to channel 2. At this point, we have a lot of draw in our correlation today. I can hear that through the headset. So we'll scroll down to OK, hit enter. And now the SeCorrPhon receiver is asking us, do we want to enter pipe data? And we say yes by either hitting this enter button or the jog dial. If we just press the jog dial, that will also enter the data. In our case here today, we're listening to one section of pipe. We have one length of 8-inch cast iron pipe. To scroll in the length, we can either use the jog dial to go up or down. In our case, we're going to scroll up to 675 feet. There we go. We can also enter this data by scrolling across using these buttons and go up or down accordingly. In our case, we will enter that information by hitting the enter button. The next prompt is, what is the pipe material? In our case, it happens to be cast iron, so we'll hit enter. Cast iron and ductile iron are very similar sound velocities. We're going to scroll down to 8-inch diameter, hit enter. Now we're going to start our correlation. And before we start the correlation, on the screen you'll notice that it reviews the data that's been entered. We've entered 675 foot of cast iron, 8 inches in diameter. And the sound velocity for that is 3,937 foot per second if this were a brand new pipe. We hit enter. And now the unit is taking its first 32 noise samples. And as it's developing its data, it's listening, and you'll notice on the screen there are many peaks. And the reason for this is that we have probably some power harmonics here. It's hearing noise in a lot of places equally dispersed across the length of the pipe. As it's finished its correlation, you'll notice that the time delay in the little square box here is 141.6 milliseconds. What that is the time delay that one microphone heard the noise before the other one. So one microphone hears the noise first because it's closer to that maximum noise sound, and then the second microphone hears the same noise, but it is further away, and therefore it takes longer time for it to get to it. We can now scroll down to continue, hit enter, and now we're taking more noise samples to see if we can clean up our correlation a little bit. As it takes more noise samples, a lot of times for a demo, what we'll do is we'll set up the microphones on fire hydrants. We'll have 3 fire hydrants in a row. We'll set number 1 up at the end fire hydrant, number 2 at the opposite end of our pipe run, and open up the center hydrant as a demonstration to show that you can find a leak. Right now we're in water restriction, so we don't do that. We noticed as we continued that the sound velocity changed to 78.6 milliseconds, meaning that the time delay that was heard has been reduced. If this were a real leak noise situation, not just an illustration of how the equipment works, we would look at 182 feet from transmitter and microphone number 1. And at that point, we'd look around and see if there were any valves, water services, or fittings that we could listen to see if we could pinpoint the leak noise. Since this is a rather long distance, what we can do is move the transmitters closer together and do another correlation. By doing multiple correlations, you're increasing the likelihood of success by having all those correlations bring you to the same spot. When that happens and you can hear the leak noise with a ground microphone, then it's safe to mark it as a leak. If we don't hear a leak noise and we can't correlate to the same spot, we can't really call it a leak. Well, thank you for joining us today. I hope you enjoyed the demonstration of the SeCorr phone.